All right, what's going on, everybody? Today we're going to be doing another LeetCode problem. This one's called merge k sorted lists. We're basically given an array of k lists called lists. Each of those linked lists are sorted in ascending order. They want us to merge all of those linked lists into a single linked list, sorted in ascending order, and then just return that list. We can do this in place. So for example, if we had these three lists here, they basically just want us to combine those into one big sorted list and then return that, and we can do that in place. So let's get into the whiteboarding. So I drew up a little something beforehand here. So this is basically just represents our vector of list node pointers, where each list node pointer has a list. This vector would be size 8 here, and these numbers represent the indices of each list. So the first thing I thought when I saw this problem was to do a big O of n times k solution, where n is the total number of nodes and k is the total number of lists. Basically where you just cycle through every single list in each iteration, you pick out the smallest node and then you add that to the new list, and then you just keep doing that over and over again. So that would be big O of n times k, but we can actually do better. If we use our knowledge from the LeetCode easy problem, merge two lists, we can actually come up with a big O of n times log k solution. So let me make a note of that. So the algorithm I'm going to be going over in this video is going to be big O of n times log k, and n again is the total number of nodes in our in all of our lists, and then log k, or k is going to be the number of lists we have in our vector. So let's just go ahead and walk through the algorithm I'll be implementing. So the first thing, we're going to need a couple things, right? We're going to need a helper function called merge two lists that'll basically just help us merge two lists in our merge sorting outer loop or outer algorithm. So the first thing we want to do is just take note of our initial length of our vector. So at first, that's just going to be 8, right? Because there's 8 lists here that are given to us. And we want to loop while, basically while our length is greater than 1, because we want to merge all of these, keep merging them together basically until there's only one list remaining, and at that point we return that list. And I'll keep that list at the very front of this vector in my implementation. So we have this length, and we're going to loop while it's greater than 1. And we're going to be changing this length, though. I'm not going to actually be changing the size of the vector to save unnecessary space or time complexity, to save us from unnecessary operations. So I'll just be modifying this number and then indexing into the vector appropriately as we resize this kind of artificial length marker. So we're basically going to have, inside of this for loop, we're going to want to loop while our length is less than, or while we're going to have an iterator I, and we're going to increment that by 1 while it is less than the length divided by 2. So our length divided by 2 is going to be, and we'll call this half. At first, it will be 4, and this number is going to get updated as we keep cutting this in half, the number of lists we have in half. So half is going to be 4 at first, and we're going to loop basically while I is less than half. And what we're going to do at each iteration is we're basically going to call a merge function, and I'll just call that m for short. We're going to call a merge function on, in the indices we're going to call this on, it's going to be on I, and then it's going to be on basically the length. So we call that len. It's going to be length -1 minus I, just to get the last index of the length of the the last index based on our artificial length here. So half is 4, and then after this, the way we're going to update our length is we're just going to, we want to divide our length by 2 every time we're done with this inner loop. But to account for odd numbers, we're basically going to just add 1 to the length and then divide it by 2. And that'll handle the cases where we have an odd number of lists. So let's just get into the algorithm here. So I at first here will be 0. So just mark this. So I is going to be 0. And then our last index will be 7. So the first thing we're going to do is basically just merge this 0th list and then this 7th list. So to do that, so we have 1, 3, and then this is where our merge to list helper function will come into play. So it'll be 1, 3, 7, 10, and we're going to store that work in this 0th index here, because remember I said we're going to use this first index here to ultimately have our entire big list. So so the way this is going to work is we're going to basically merge a bunch of smaller lists, and then we're going to go on to merging medium-sized lists, and then we're going to ultimately go on to merge larger lists into one big list. It's kind of like a pyramid in the sense that the algorithm has logarithmic time complexity. So let's just get started with that. So we'll have 1, 3, and then 7, and 10, and then technically there will still be a pointer here, but we don't need to worry about it anymore, so I'm going to erase it. So I is going to increment by 1, and that will now be 1, and then the second to last number here, so that'll be 6. So now we're going to merge the 1th list and the 6th list, so that'll be 5, and we're going to store that in the 1 at list I here, which is 1. So 5 like that, and those are so that's another iteration of this inner loop. Okay, so we're going to increment I again, and we're doing this while I is less than half, and half right now is 4. So so we have a couple more iterations to go. So 2, and then this value will be 5. So we're going to merge this second list and the 5th list. So we'll have 3, 4, 4, 7, 9. So 3, 4, 4, 7, and 9, and then this, we're done with this these pointers over here, so we can erase that. And then one more iteration here, and then at that point half will be 4, and we can stop iterating on this inner loop. So I will now be 3, and this will be 4. So so we're going to merge the 3rd list here with this 4th list. So we'll have 1, 2, 3, 4. And then we're done with these pointers. And as you can see, we just cut our work in half. So that's like basically the first phase of the first iteration of the logarithmic part of the algorithm, right? So I would now be 4, we'd be done iterating there. And we can cut our length in half now. So our length, our new length is going to be 4. And we're gonna still keep going, because we're gonna keep doing this while length is greater than 1. So half of 4 is going to be 2, So, and then we're going to do the same thing again. So I is less than half. So I at first is going to be 0, and then the length is 4 minus 1 minus I is going to be 3, right? And that corresponds with our last list here. So again, we'll merge this first list and the 0th list, sorry, and the third list. So that'll be 1, 2, 3. So let me just make a note here. So 1, 2, 3, 3. So 1, and there's actually 2 ones, right? So it's a good thing I'm being a little tedious with this, or pedantic with this. So 1, 1, 2, then there's 2 3s, we got those, and then there's a 4 and a 7 and a 10. So I'm just doing the same merging. There's just more numbers here, so I'm trying to make sure I don't forget any to keep things consistent here. So 1, and then we have a 2, and just 2 more numbers here, 7, and then 10, and then that should be all of them. So 1, 1, 2, 3, 3, 4, 7, 10. Perfect. Okay, so that's the merge of those two lists. We're going to increment I by 1, so it'll be 0, or it'll be 1 rather, because we just did 0, and then the new length is 4, so 4 minus 1 minus 1 is 2, which corresponds, of course, to this list. So now we merge this first list and this list. So we would get 3, 4, 4, 5, 5, 7, 9. So 3, 4. And that's those two lists merged. Okay, so now I would become 2 and we'd be done looping. So again, we're going to cut length in half. So length would be 2, and we're looping while length is greater than 1. So this is going to be our last iteration of this outer loop, and that corresponds, as you can see, with the 2 big lists we have remaining. So this is the last part of our logarithmic, the outer portion of our algorithm, which is logarithmic, right? We're just combining these last 2 big lists. So in doing so, I'm not going to rewrite all of this again. I'll probably just repoint some arrows. So, but you know, this I is going to be, just to show this again, this will be 0. And then this, of course, will just be length is 2. So this will be 1. And that corresponds to these lists, right? So we have 1, 1, 2, 3. So this will point all the way back to this. And we have a 4. So this is going to point over to this 4. Getting a little crowded here. And then this will go back to the 5. But, you know, in essence, I think you get the idea. So 5, 5, 7, and I'll just complete this anyways. So that's basically the end of the algorithm. And then, of course, we're just going to return that first index of our list vector, right? Because that's the head of our final sorted list. So again, this is going to be big O of n times log k time complexity, because we're to kind of reiterate that explanation for the why it's log k. It's because we're starting with by merging smaller lists, and that cuts our search space in half, and then we're merging lists that are a little bit bigger and a little bit bigger until we have 2 lists left, and then we merge those together, and then we're done. So let's go ahead and get into the code for this. So the first thing we'll do is I'll code the outer portion of the function. We can have a couple edge cases, right? So if list is empty, we could just return null. If list has one list, we can just return that one list, right? So let's do those edge cases. So if list empty, so basically if there's no list, we can just return a null pointer. Otherwise, if the size, we can check if the size is just 1 to speed up our algorithm or speed up this function a little bit. And then we can just return the iterator to the front of that list, right? Because that'll be the list at index 0 pretty much, but more safely. So that handles the case where there's only one list. So we need to get that length, right? So the initial length is just going to be the size of lists, right? So we'll have an integer called length. It's not going to be constant because remember we'll be updating this. So it'll be list dot size, and we're going to have an outer loop where we just loop while our length basically is greater than 1. Right, so until all of those lists, basically while we don't have a single list remaining. And then our inner loop, we're just going to have C-style for loop. So for an I equals 0, well, I is less than. Basically, we need that half variable though, right? So because we could just say length divided by 2, but I like making a variable for this, and in fact we can declare it out here so we don't have to keep redeclaring. So in half, and then we'll assign the value in here. It'll always be the length divided by 2 in this inner loop. So we're going to increment I while it's less than half. And then we're going to call a custom function, and we're going to need the pointer to 2 merge lists that we're merging right at this point of the algorithm. So and we're going to set those to the index at list I, or the element at index I, right, in the list vector. So we're going to say merge 2 lists, and we're going to write this function at the end. So merge 2 lists, and we'll call that on lists I and the last list. So list, or it'll be length minus I minus 1, or minus 1 minus I. I mean, it doesn't really matter, but I like that order better. Like, makes a little more sense to me. Anyways, yeah. So we're going to be merging those 2 lists, and then after that, we need to update our length variable, right? So that length marker will become length divided by 2, but we have to account for odd numbers, or odd number of lists, right? So we really need to add 1 there. So like if we had a 9, and we were to just divide that by 2, it would give us 4, but we really want 5. So to fix that, we'll just add 1. So we would, if it was like 9, we would get 10 divided by 2, and then that would be 5. So that'll fix that. And then at the end of all of this, we can just return that list that's at the front of the list vector. So we can say list.front. That's pretty much it for this part of the code, we also need to write that helper function. This is just the LeetCode easy merge, where you merge two lists. So it's going to return a node pointer, and we'll just call it merge to lists like I did down here. It's going to take two list nodes, so just two parameters, both list nodes, both the heads of lists that we'll be merging. So just to handle some edge cases first, if neither of those lists have elements, which I don't think should ever be the case in the context of this, but we'll just write a complete function here just to practice good code. So both of those pointers are null pointer. We can just return null pointer, right? That would be the merged list of two null pointers. Otherwise, we'll handle the cases where one of them is just one of them is a null pointer. So if L2 was a null pointer, we can just return the list for L1. And there should be an else if L2 is a null, or L1 is a null pointer, we can return the pointer for the list L2. Otherwise, we know both of those lists are going to have at least one node in them. So the way I'll do this is I'll just say, we'll actually create a dummy node first. So just to keep track of the head of this list. So we'll say list node dummy. We'll allocate space for a new list node. And I'll have a current pointer so we can keep track of where we are in the merged list. I'll call it cur. That'll be dummy at first. And then we're going to say while there is still a node present at our pointer in the list L1 and the list L2, we're going to pick the smaller of the two nodes. So if L1 val is less than L2 val, then we'll basically just add that node to the new list. So we'll do that by setting cur, assigning the pointer for cur next to L1, because that's the smaller node. And then we need to slide down the list L1. So L1 will be equal to L1 next. And then we can do the inverse of that. So else if we don't need to have the statement here, because we know L2 val will either be less than L1 or equal to L1 val, right? So cur next will be equal to L2, and then L2 will be equal to L2 next. And then we also need to slide down the combined list. So cur will be cur next. And then after that, we need to account for if there's still elements in L1 or L2, right? So if L1, and we know that one of these lists has been exhausted, so you can just say if L1, if there's still elements in L1, then cur next will get assigned to the rest of those elements. Same thing for L2. So else if L2, then cur next will be L2. And then finally, we just need to deallocate the space for this dummy node, and then we can return the pointer to the head of our list. So I'll zoom out a little bit. So to do that, I'll just recycle the current node. I'll set that to dummy, and then I'll slide dummy down to dummy next. Then we can just delete cur, because that points to that dummy node space that we allocated. And we still have track of the head of our new list. That'll be at dummy, right? So we just return dummy. That's pretty much it for the code. So let's go ahead and submit this. Just make sure it works. So it beats 84% with runtime and then 63% with memory. Again, this time complexity is going to be big O of n times log k, where n is the total number of nodes, right? Because one of those lists could potentially have almost all of the nodes, and then k is the number of lists in the vector, because we're going to be iteratively basically cutting the number of lists in half. So space complexity should be constant, because we're doing this iteratively. There's no recursion or any other data structures. So yeah, so hopefully this explanation helped you understand this problem better. If it did, leave a like and subscribe. Helps the channel. So thanks, and see you on the next video. Peace.